I'm going to do this tricky little integration here. I want to give you two ways to sort of look at it, and you can decide which way you think makes more sense. There's a way that I like to do it, and there's a way that your textbook does it, but they both result in the same kind of work. So first, let's try my way. So I'm going to write it again, but this time I'm going to move that x squared to the top. So when I move it to the top, it becomes x to the negative 2, and I'm going to multiply it by 6x plus 5. And I still haven't integrated it, so I still need the integral sign with respect to x. Now, if I expand those brackets, I'm going to get x to the negative 2 times x to the 1 is going to be x to the negative 1. So I'm going to get 6x to the negative 1, and x to the negative 2 times 5, I'm going to get 5x to the negative 2. And I still haven't integrated it, so with respect to x. Now I need to integrate these separately, so everything there can get integrated. You don't have to write it like this, so this is sort of not part of the working, I guess, but I'm just going to write the integral of 6x minus 1 with respect to x plus the integral of 5x minus 2 with respect to x. That's just so that you understand that the integral of this plus, the integral of this plus this is the same as the integral of this plus the integral of this. All right, so that's going to be a log, because obviously, maybe I'll just give you one more line here. That's the same as 6 over x with respect to x. And that's 5x minus 2 with respect to x. All right, so that's going to be a log. It's going to be 6 log ex, and the integral of this is going to be 5x minus 1 over 1. And I can just tidy that up a little bit. Oh, don't forget your plus c. I can just tidy that up a bit. I can say that that's log e to the x plus, and the x can come to the bottom. Oh, that should be a negative 1. So the x can come to the bottom now, and it'll be negative 5 over x plus c. And that's my answer. So that's one way of doing it. I wanted to show you the other way real quick. So rather than moving that x to the negative 2 to the top, I can split the fraction. So I can do as my first line the integral of 6x over x squared plus 5 over x squared and with respect to x. So if I add those two together, I would just get that. So I've just split the fraction apart. Now, my next line, you're going to see that the working kind of converges here, because x over x squared is going to give us 6 over x with respect to x, and 5 over x squared, I can write that if I want as 5x to the negative 2 with respect to x. Now this looks remarkably like sort of that. And from there, the same working can apply. I might just do the working, but not by splitting it into integrals here. So I might just say, let's say integral of 6 over x is log 6 log e to the x. And then the integral of that is going to be 5x to the negative 1 over negative 1, and tidy it up. But don't forget your plus c, and tidy it up, negative 5 over x plus c. All right, so two ways of thinking about things. One was bringing the x to the top. One is splitting the fraction. And another way of thinking about things, if you've got an integral of a term plus another term plus another term, you can split them up the way that I've done there, or you can just integrate one followed by the other. All right, so that tricky little example there, but you should be fine with that now.